Hello and welcome back to the Section 2 notes. This is a section about reflection. So let's kind of zoom in here, talk about our lesson objectives real quick. We want to develop the definition of a reflection using constructions. We want to describe the properties of and write rules for these reflections. We want to determine the image or pre-image of a figure after a given reflection. So what I want to talk about here is a reflection. Now, what I often think of is a mirror, okay? That's the initial thing that I think of when I think of reflection, okay? So what I want to do is kind of a little other part to the video. You don't need to write this down. Now, what we're going to do is we're going to take a picture of me, and we're going to take this, and we're going to reflect this picture over here. Okay, we're going to reflect it over a line. Okay, and here's my line, and what we're going to do is we're going to call this the line of reflection. Okay. All right, and when I reflect this picture over, I want you to notice something. When I've done this reflection, I want you to notice the KC. Okay, notice how you can see it, KC, and then when we reflect it, it's backwards, okay? And the reason why is this. When I do a reflection, all right, I want to take one point on here, and I'm going to take the point here for the edge of the C. I'm going to do that, color that in red. Okay, I'm going to call this my point A, okay? And when I reflect that over this line, what I'm doing is I'm taking this line that's perpendicular to the line of reflection, and I'm going to correlate it to another point, that same corresponding point over here, and I'm going to call that A prime. Okay, and that's true for any point on here, but what I want you to see is the reflective piece. Okay, when you guys look in a mirror, it's always opposite. Okay, this is what you look like to everybody else, but if you look in a mirror, this is what you're going to see. Okay, and yeah. Okay, so now let's talk. I wanted to do that to kind of show you what that was in real life, but over here, let's kind of talk about the notes. Okay, and it says that in a reflection, all points on the preimage are reflected across a line of reflection to produce the image. Okay, and we've got a couple different examples of that here and here, and let's kind of go in and examine, what's going on. What you see in this picture, you see, quadrilateral EFGD, and when that's reflected over to create E prime, F prime, G prime, D prime, I want you to notice something. I want you to notice how G and G prime connect, how those connect. I want you to look at F and F prime, okay? What I want you to notice about these lines is that they are not only parallel, but they're parallel to each other, but they're perpendicular to the line of reflection. Okay, so this is the line of reflection. Okay, and the other thing that I know is that segment, and we'll call this, we can call this, like, say, point B or something like that, and point C. But what I know here is that FC is going to be congruent to F prime C. All right, and so we can get that. And same thing with G, B, and G prime B. All right, so that's what's going on. Okay, so they're equidistant, to each other over that line of reflection. All right, and the same thing's happening here. All right, notice how the B's are directly across from each other. The A's are across from each other, and so is C and C prime. All right, so now let's take a look at another thing that we've already kind of talked about. It says that, what I know, if I were to connect, like, say, B and B prime, A and A prime, and then C to C prime, is that the line of reflection is a perpendicular bisector of these line segments that connect across. Okay, so we did that before. All right, and so what I have here is I know that these two segments are congruent and that this is a right angle. Okay, I also know over here that AJ is congruent to A prime J. All right, and then C and C prime, because C is on the line of reflection, it's just actually going to be you know, when we reflect that over, it's not going to go anywhere. So it's just going to stay there, and this is also 90 degrees. So whenever you know that something is reflected, you guys need to make sure you go in and you're able to draw this picture, okay? All right, so let's go into the first part. And what it says is that we have this reflection of parallelogram PQRS across this line of reflection WY, okay? And what I know, because that's reflected, I'm going to come in here and draw these pictures, okay? So I'm going to come in here and say that RZ is congruent to R prime Z, and that we make a right angle, and then that XS is congruent to XS prime, okay? And it also makes a right angle, all right? So just because we have those, all right, and so then it says this. If R prime, or R prime, if the whole length is 14, then what's the length of RZ, all right? And so here's what I've got. We're trying to find the length of RZ, so I'm going to put that as an X, okay? And if that length is X, then I know that R prime Z is also X because they're congruent, all right? And then the other thing that I know is that this whole length here is 14. Okay, so what I can do is I can set up this equation here and solve for x. I can say that, you know, x plus x is equal to 14. All right, and so combine those two, that's going to give me 2x, and that's going to be 14 divided by 2 divided by 2, and I get that x is equal to 7. All right, so RZ is equal to 7. Length of 7. So, you know, you don't have, you know, if you can do that in your head, go ahead and do it in your head, but, you know, there's a way to do it this way. Now, they also say over here that SX is equal to 5, okay? So this length over here is 5, then that means that also SX, or XS prime is also 5. So I would write that this is S prime and then X, okay, because X is the point on the line of reflection. All right, so now let's talk about what happens here. When we have reflections, what they do is they preserve segment lengths and angle measures. Now, preserve means that things don't change, and a lot of you are going to have that question of what does this mean? Okay, what does the reflection preserve? And what that means is that things don't change, okay? Things don't change. Okay, specifically, the lengths, okay? The lengths, those are the things that don't change. Put an E on the end. And angle measures don't change. Okay, now the thing that happens is reflections do not preserve orientation. Now, orientation, that word means the position, okay, the position of the object, okay? And so let's kind of like look at the, you know, past example up here. What I know is that, you know, you got to think of the position of the object. So this parallelogram is kind of like pointed straight up like this. In this parallelogram, although this, you know, the distances in each parallelogram are going to be the same, but you know, they're gonna orient themselves different. Okay, and let's kind of take a look at this other example down here. Now, what I know is that triangle JKL, okay, this triangle is mapped to J prime, K prime, and L prime, all right, and that's what that means here, all right, that this is mapped, all right, and it's done through a reflection. Now, here's what I know, okay, because that's reflected, and that's all that's that's all that's happening here. Here's what I know. I know that JL, or let's do JK, okay, is going to be congruent to J prime, K prime. Okay, I also know that KL is going to be congruent to K prime, L prime. All right, I also know that JL is going to be congruent to J prime, L prime. All right, and then I also have this about the angles. Okay, angle L is going to be congruent to angle L prime. Okay, angle K is going to be congruent to angle K prime. And then angle J is going to be congruent to angle J prime, all right? And so that's, you know, what we know about reflections, okay? I can move it over and reflect it across this line of reflection here, and I'll get the same shape. It's just going to be oriented different. Now, notice here, okay? Notice how the L is on the left side, okay, of this triangle. Now over here on the reflection, it's on the right side, and that's what orientation means. Okay, so things aren't going to be the same, but the segment lengths and angle measures, those do not change. Okay, so let's talk about this in a coordinate plane. So let's talk about this. You know, if I have this figure here, okay, what's going to happen is I can reflect this across the x-axis. Okay, and a cool thing happens when you reflect across the x-axis. You get this thing called a rule, all right? And so if I reflect, so R, so here's my rule. Okay, R stands for reflection, okay? That's what that little thing means, little r. So if I have a reflection across the x-axis, this is your line of reflection, okay? And what's going to happen is that anytime I take any point x, y, in order to find the new point, okay, so here's my pre-image, all right, my pre-image point, whoops, pre-image, okay, and that's my OG, to my image, okay, what's going to happen is that you take any point x, y, and then you keep the x value, but you make the y value opposite. So I'm going to write here that we keep x value, and we're going to make the y value is opposite. So the y value is opposite. All right, and so it's kind of hard to read those, but I want to make sure that as I go through this, you guys are able to read these rules and make sense of what those mean. All right, so I'm going to come down here, and it's going to ask us, what are the coordinates of the image of vertex P after a reflection of R, okay, R over the reflection over the x-axis of point xy. Okay, so what I'm going to do is this. Okay, I'm going to do a reflection for this whole thing here. And so what I'd want to do, remember, we keep the x value the same, but we make the y value opposite. So this is going to give me, if I've got the point -7, -4, okay, to find P prime, what I'm going to do is I'm going to take -7, keep that the same, but I'm going to make 4 opposite. So that would be the point -7, 4. And I'm going to plot that right here. And I'm going to call this P prime, and that's going to be -7, 4. All right. I'm going to do the same thing with S prime. That's going to be 4. -4 is going to turn into 4, 4. Okay. And that's S prime. And that's going to be 4, 4. If I take point Q, keep the x value the same, but make the y value the opposite. And so we're going to get -7, +10. All right. And that's going to be Q prime. Okay. -7, 10. Okay. And then on the other one, where it's going to be 4, -10, it's going to be 4, +10. Okay, so it's going to be R prime. All right, and that's going to be 4, +10. Now, if I just connect these lines here, all right, then I've got my reflected shape. Okay, and that's all we're doing. Okay, and so what you also can notice here is that like the distance from S prime to S is a length of 4. Okay. I'm sorry, a length of 8, and that this length here is congruent to that length here, all right, and they form a right angle. All right, same thing with the other points, but I'm not going to draw those, okay? So the point for P prime, all right, based off of our rule, okay, you don't have to always draw that, but, you know, if you know the rule, you can automatically just answer that question and say that P prime is going to be -7, 4, and that's your answer, okay? Okay, let's take a look at another one. Trapezoid KLMN has been reflected across the y-axis to create trapezoid K prime, L prime, M prime, N prime. Okay. Now what we're doing here is doing something a little bit different. Okay, we're going to reflect this across the y-axis, and I want you to see what changes here. Okay, so to go from point K is the point -1, 3. Okay, it's over here. -1, 3 is point K. What's K prime? That's the point 1, 3, okay? So this gets mapped to the point, to K prime, which is going to be the point 1, 3, all right? It's kind of interesting. All right, on the next one, we've got point L, all right, and that's over here. That's the point 1, -2. Okay, if we reflect that over, that's going to be -1, -2. All right, so L prime is going to be -1, -2. All right, and let's look at point M. Okay, and so point M means that I've got -4, -2. If I reflect that over, M prime is going to be +4, -2. All right, so M prime is going to be +4, -2. Okay, and then hopefully you're seeing a pattern here with this. And so if I look at point N, that's the point -2, 3. If I reflect that over, that's going to be the point 2, 3. So N prime is going to be the point 2, 3. All right, and so think about what's happening here. To go from K to K prime, what's changing? The Y value is staying the same, but the X value is becoming opposite. Okay, and that's happening in each of these. And so what I want to do, let's say that, you know, in all these points, I'm going to put an arrow up here, the X value is opposite. Okay, so if I wanted to come up with a rule for this, remember the R stands for reflection. Okay, this is your line of reflection. Okay, this point here is your OG point, your image. I'm sorry, your pre-image, and then if we were to reflect that over, that's going to give us a rule of -x, comma, y. Okay, and this is our rule for reflecting things over the y-axis, and that's what we were doing here. Okay, now let's take a look at the next page. Okay, let's take a look at this top one. This got a little bit cut off, but we'll be okay. And so what we're doing here is we have a reflection here over the line y equals x, okay? So this here is my line of reflection, okay? And what I'm doing here, instead of a horizontal line or a vertical line, we're doing a diagonal line here. And it's, you know, what you can notice here is that it has a slope of 1, y-intercept of 0. That's that line y equals x, okay? And so we describe that. And so what it wants us to do, it wants us to take the pre-image and map it onto the image and then come up with a rule, okay? And so what I have here is I have, you know, let's not do point D yet. Let's do point E and E prime. Now the point E is the point 1, -1, okay? And so what I have with that is I have, you know, if I were to find the other point, you know, its corresponding point over here, this would be the point -1, 1. Okay, so this is going to give me -1, 1. Okay, if I were to look at the point F over here, this would be the point 5, 1. Okay, and if I were to reflect it over the line y equals x, what happens is it becomes the point 1, 5. Okay, so this is the point 1, 5. Now, what I want you to realize here is that there's something that's happening. We're switching our x and y values to get our new point. So if the point D is the point 2, -4, way down here, D prime is going to be -4, 2, and we're just going to go -4 up 2, and there's that point. Okay, so this is going to be the point -4, 2. All right, and so what is the rule that describes the reflection across the x-axis? Or I'm sorry, not the x-axis, the line y equals x, and that's going to look like this. All right, it's going to look like R over the line y equals x, okay, of the point xy, and what that's going to do is we're just going to then switch that to become the new point y, x. Okay, so remember, this is your OG, this is your pre-image. Okay, and then this is going to be your image. And to get those new points, all you're going to do is just switch your x and y value. Okay, and so let's write that. Okay, to here, all right, all we're doing is we are switching x and y. All right, and that's it. Okay, let's take a look at the next one. Okay, and they give us this graph here, which says, reflect triangle ABC across the line y equals negative x. Okay, that's this line going in this direction. Using the rule, reflection across the line y equals negative x of your original point xy means that you switch your x and y and make them opposite. Okay, so I'm going to write that here. That this means we're going to switch x and y and make them opposite. All right, so now let's take a look. If I were to do say triangle ABC, okay, and if I write this out here, triangle ABC is going to get mapped to triangle A prime, B prime, and C prime. Okay, and when I do this, okay, B is just going to map onto itself. Okay, it's just going to stay on that line of reflection. But I notice that the point C is the point 1, negative 5. Okay, so B is going to stay itself. So B is the point, what's that, 1, negative 1? So 1, comma, negative 1. Okay, point B is going to get mapped to B prime. And because it's on the same line, we're just going to get 1, negative 1. Okay, it's on the line of reflection. It's not going to change. Okay, but let's talk about point C. Okay, point C is the point 1, negative 5. Now remember what I want to do to get C prime is we're going to switch our x and y. Okay, and so we're going to get 5 and 1. And we're going to make them opposite, all right? Because this value is negative 5, that means that this value here is going to be positive 5, okay? And then the 1 is going to become negative. All right, so let's just go ahead and find that real quick. Let's do 5, negative 1, and that's going to be point C prime, okay? That's going to be C prime, all right? And let's go ahead and find A prime. So we'll start with A, okay, and if I write A, that's going to be the point negative 4, negative 5, okay? And if I were to go through and find A prime, then I would switch those and make them opposite. So I would do positive 5 and positive 4 to give me A prime. All right, so if I come over here, if I do positive 5, 4, it's going to give me this point here. All right, and so notice here that if I connect these, then I have a reflected thing, okay, over that line, all right? And that's all we're doing, okay? Okay, let's do the same thing here. Rectangle Q prime, R prime, S prime, T prime was created using the rule, you know, reflection over the line y equals negative x of xy gives us negative y, negative x. So what we want to do is we want to graph the pre-image of the figure. Now the first thing I want to do is come in here and kind of draw in our line of reflection. All right, and that's going to start here at my origin, a slope of negative 1 all the way down, slope here, okay. Okay, and so what we got, okay, and what you can do, you can kind of do this kind of quickly. You come over here and just say that this is Q. T is going to stay where it's at. S is going to be right here, okay, and then R is going to be like that, okay. And let's think about what these points are. T prime isn't going to go anywhere, so I'm not going to do that. But Q prime, okay, this point here is the point negative 2, 4. Okay, negative 2, 4. And if I wanted to do Q, I would switch those and make them opposite. So I'd get negative 4, 2. Okay, to get S, that's going to be 4, 2. I'm sorry, S prime is 4, 2. To get S, we want to do negative 2, negative 4. Okay, negative 2, negative 4. All right, same thing for R, that's going to be 4, 4. Whoops. And so then R prime is 4, 4, and then R is going to be the point negative 4, negative 4. Okay, and you can just draw them there. So you don't need to write out all the points all the time. Sometimes it really helps. Sometimes it's what the question asks you to do. But I would just be able to read this and know what it's saying. okay? And that means we're going to switch our x and y values and make them opposites. Okay, on the last one, here's what we've got. Okay, it says, what is the created preimage of vertex A prime, okay, if the rule that created the image is that we're taking R, or reflecting over the y-axis, points xy to get negative xy. Okay, so if we're doing this over the y-axis, let's put that in here, that this is our line of reflection. Okay, and if the point A prime, okay, is the point 4, 2, okay, then to go backwards to get the opposite x value, okay, this is opposite, all right, to go backwards and to find A, it's going to be over here, okay, and this is going to be the point negative 4, positive 2. So all we did was just switch our x value, okay, and so that's the original point A. All right, and you can also tell it because it's 4 units away here, and it's 4 units away here from your line of reflection. Okay, so a number of ways to kind of look at these problems and do them, but as long as you understand what it's asking you and some of the vocabulary, you're going to be all right. So we'll see you guys in a bit. Thanks a lot. We'll see you. Okay, bye. Okay, seriously, I'm leaving. Bye. Okay, I'm really leaving this time.